Hello everyone. In this lesson, we will review an important concept in algebra, the exponent and the radicals. We also learn how to convert between the two, from exponent to radical, and perhaps from radical to exponent. We also have to review the very basic operation of exponent, which I am listed them all here for everyone. And the fractional exponent is very important. This shows the relationship between the exponent and the radicals. Also, we have to review the concept of radical, how to simplify, and the operations of the radicals. Why are we reviewing this? Okay, so the reason we are reviewing this because before you can work with any calculus problems, you need to master this concept. So I'm going to provide everyone with some idea about what formula that we need to use for calculus in this case. So you see, in calculus, there are two major operations, which you will learn right away. It's called differentiate or finding derivative of a function. Derivative of a function is basically a slope of the line tangent to the curve at a given point. And the notation for that is derivative of a function x raised to exponent n, and c is a constant multiplied by this function. You have to differentiate, or you take derivative of this function as a function of x. So what you need to do is you need to take the exponent multiplied by the coefficient in front of x. At the same time, we have to take 1 away from the exponent. So this is the basic rule for derivative or differentiation. It's one of the operations in calculus. The next operation in calculus is called integration. So this formula is representing an indefinite integral of x raised to a power. So I have a function x raised to exponent n, and I have a differential factor of dx. So the integrals and the differential factors goes together in this case. So in order for me to integrate this, I need to add 1 to the exponent and I divide it by the result. So derivative and integrals are kind of reverse operation of each other. And in this formula, you can only do this when you have n is not equal to -1. Okay, so before you can apply or work with any of these formulas, you need to master the concept of exponent and radicals, because most of the time a function is given to us is not in the exponential form, it's probably in the form of the radical. For example, I can give you a function like square root of x, so you need to know the exponent form, so you have to convert that into x to the exponent 1/2. You have to pull out the exponent before you can differentiate or finding the derivative, or before you can find the integral of certain function. Okay, and not too many function is as simple as the square root x, which is the parabola open to the side. It can have this form, such as -2 divided by x to the exponent 3. And you have to know how to convert this x to the exponent 3 correctly before you can apply it into calculus. Right? Okay, so I list 3 important formulas for us to pay attention to. Okay, and it's also associated with this 3 example that I give below here. Alright, so let's start with a lot of them. I actually have quite a few questions to work with. I designed like 15 questions altogether, and hopefully I can complete it in 30 minutes. It's actually very simple. It's just a practice conversion between the radical to the exponent, and at the same time, I would like everyone to take a look at the formulas that we have here for derivatives and for integration. You see, x is as a numerators. Okay, so here you don't have a denominator in this case. You just have a function of x raised to exponent n, x raised to exponent n. So in the case that you have x as a denominator, then what you need to do is you have to convert that to a function as a numerator. So you have to rely on these formulas here in order to bring that x up and make that into a numerator. Okay, and you can just leave your constant as the denominator in this case. So that's why in this example I asked everyone to write the following expression as exponent with no radicals and no exponent as the denominators. Okay, so you can have a coefficient or a number as a denominator, but as soon as you have the x, you need to bring that up to the numerators and you apply these formulas. Combine with these formulas and combine with these formulas. Alright, so that gets started. So you have 3 times the square root of x. So this one is pretty simple, right? Square root of x is to the exponent 1/2. We all know that. So this number 3 here is a coefficient multiplied by the square root of x. So I don't want everyone to confuse that this 3, you may think this is the cube root of x, which not supposed to be, because if it's the cube root of x, that number 3 should be written tiny, the tiny 3 should be written right in there. Okay, so when there isn't any number, it is a square. So in this case, you have a square root. Alright, okay. So I will write it as 3 raised to the exponent 1, okay, but multiplied by x to the exponent 1/2. Okay, so you convert the radical to the exponent. In case that you have a function 3 times square root of x, you need to differentiate, okay, or take derivative, or you have to integrate, then you have to convert that to the exponent. So the next one, you see the difference between number 1 and number 2 in this case is, you see the number 3. Now, if I write this number 3 in this form, okay, so then that means it's the cube root. Okay, so in this case, you should have minus 5 times x raised to the exponent 1/3. Alright. Okay, so this is very simple to recognize. Is this kind of solution kind of explain themselves? Alright, so when I come to number 3, I have negative 2x as the radicand here. Alright, and then this is like an index of 5. So what I can do in this case is I will write negative 2x, okay, all the way to exponent 1, and there's my index of 5. Then I can use the formulas of, I listed up here for everyone, okay, so a raised to exponent m, the index is n, so to convert that to exponent, the exponent, the numerator is m, and the denominator is your index. Okay. So in this case, now I can write it as negative 2x, all of it to the exponent 1/5. Okay, so don't forget the negative 2 is underneath this 5th root as well. So that's we have it. And if you want to expand a little bit further, you can write it as negative 2 to the exponent 1/5, and then x raised to the exponent 1/5, because I can use these formulas. If I have a product inside a bracket, and I raise both of this to the exponent n, then I can raise each of this to the exponent n. Okay, so many formulas that we can apply in this case. Alright, so for number 4, okay, so I should write 5x raised to the exponent 2/5, right? Okay, so this should be very simple. And the reason I have this question, because I want you to compare number 4 and number 5. I would like you to see the difference in this case. Okay, so different in this case is I have 5x in the brackets, all of it raised to exponent 2, right? Okay, so, but for question number 5, x is only for, the square here is only for x. I'm sorry. Okay, and it's not for the number 5, because then I don't have the bracket in this case. So let me expand number 4 a bit further. Then you will see the difference between the two in a minute. Okay, so that, very good. Okay, so what I have in this case is I will write a fifth root of 5x squared, all of it raised to exponent 1. So to make things easier for me, I will write it like that. Then I will write 5x squared, all of it raised to the exponent 1 over 5. Okay, so now I will raise each of these to the exponent. So 5 raised to the exponent 1 over 5. X squared, I raised it to the exponent 1 over 5. So in this case, I should have 5 to the exponent 1 over 5 times x raised to the exponent 2 over 5. Okay, you see the difference between these two? So the difference is, this one is 2 over 5 as the exponent for 5, and this one is 1 over 5 as the exponent for 5. So there's a huge difference between number 4 and number 5 when we don't have the brackets surrounding the 5x in this case. Okay, so the exponent 2 only applies for the x. It doesn't apply for the number 5. Alright, okay. I don't know what else that I need to remind everyone. Yes, I do need to remind everyone that I would like to ask you to remember these formulas. If I have a power raised to an exponent, that means I have to multiply the two exponent, and then I applied it in this case. Okay, so apply like square, I multiply that by 1 over 5, I have 2 over 5 as the answer. Okay, so now we'll move on to number 6. So this is pretty simple. Okay, everyone probably know that already before I say anything. So just to clarify, I will have 2x minus 3, all of this to the exponent 1, like 2x squared minus 3, all of it to exponent 1. Then I can write it as 2x squared minus 3, all of it raised to the exponent a half. Alright, and we stop here. We're not going to expand this any further. The reason for that is you raise this to exponent a half, and that's it. Okay, so that's how you convert this whole radicand into that exponent of a half. Alright, so let's compare number 6 and number 7. Alright, so number 6 and number 7. You can see that I have all of this raised to exponent 1 as a radicand, then I convert all of it to the exponent a half. But in this case, the 2, right here as a radicand, I have to be very careful. And before I can do anything with this, I will need to do two things. So I will need to remember these formulas. Okay, if I have the end root of a times b, I can break this into two roots, multiply with each other. I'm sorry, I just want to pause a few seconds and take a sip of tea. Thank you. Alright, so now I will break this into two. I will break this right here. Okay, so where the product is, I will have two radicals to work with. So you see I have the cube root of 2 multiplied by the cube root of x plus 5, all of it to exponent 2. Then I can have this at 2 to the exponent 1/3, and I multiply this with 5 plus, x plus 5. I'm sorry, x plus 5 raised to the exponent 2/3. Okay, so that's one way of doing this. Another way you can do this is this. cube root of 2 times x plus 5, all of it square, and you can write it as you raise this to exponent 1. Okay, so then what you have, you have 2 times x plus 5 square, all of this raised to the exponent 1 over 3. Then you can apply 2 raised to exponent 1 over 3 times x plus 5. 2 times 1/3 will be 2 over 3. And then you have the same thing to work with. Alright, so it's a few steps that you can do in this case, and they all be just the same. Alright, the answer should be the same in the way that we analyze the exponent and the radicals. Okay, so for number 8, this is actually very important. This number 5 as the denominator, you must leave that as a denominator to avoid any unnecessary mistake. I recommend everyone to do this step before you start bringing the x to the numerators. Okay, so you want to analyze your denominator first. The square root of x, you can write it as x raised to exponent 1/2. Excuse me, I'm sorry. And then, because you only have to raise x to the negative exponent in this case, and you can leave the 5 in the denominator. So in this case, I have 3 over 5 multiplied by x to the exponent negative 1/2. Okay. Alright. Okay. So for number 9, so again, I would like everyone to pay attention to number 8 and number 9 and compare the difference between these two. Okay, so the difference between these two. The difference between these two is this. So for number 8, 5 is outside of the radical. 5 multiplied by square root of x. In this case, you have the square root of both of the 5x. So again, the same step that I ask everyone to try. That means you are going to analyze your denominator before you do anything else, right? So you can write it as 5x, all of it, to the exponent 1/2. Okay, so all of it is raised to the exponent 1/2. So when you raise this to the exponent 1/2, it means that you are going to write negative 3, 5 to the exponent 1/2, and then x to the exponent 1/2. Okay, then now I can leave the 5 to the exponent 1/2 at the denominator, and then I can bring x up and make that into the negative 1/2. Okay, very good. Okay, so for number 10, this is actually very simple. I can write negative 3, all of it, like x squared minus 1. Here's 3 over 5 as a denominator. So I just simply bring the entire x squared minus 1 up and raise that to the exponent negative 3 over 5. Okay. So I have a few more. Okay. The reason I'm going over this type of problems is that most of the time when you differentiate or you integrate your function, you don't have a simple function like this. Your function can be in this form as well. Okay, so, and then up to this form here that you can go ahead and take derivative of this function, or you find the integral of this function. Okay, so for number 11, let's see if I want to make any comparison between these two. No, I think I would like everyone to pay attention to number 11 and number 12 and see the difference between these two. Okay, so for number 11, is just simply as -1 divided by 5 times x squared minus 4, all of it raised to the exponent 2/3, and I just simply bring -1, I just simply write it as -1 over 5 and x squared minus 4 as raised to the exponent -2/3. Okay, but this number 12, the 5, is actually inside as a radicand, so I will have to write it like this. Okay, so -1. Here you can write 5 to the exponent 1/3. Okay, then you multiply this with x squared minus 4 raised to the exponent 2/3. Okay, then what you do is -1 over 5 to the 1/3, and then x squared minus 4, all of it raised to the exponent -2/3 as the numerators. Alright, okay. So the next question is, I may have to do a few calculations, or I don't have to do any calculation here at all. Okay, so because I may have to simplify my expression a bit, but in this case, I can write the x as a -1/2 on top. So I should have 1 over 5, okay, and I should have x plus 1, and then multiply that by x to the -1/2. Okay, simply just bring the expression with the x to the numerators and convert your exponent properly. Alright, okay, so number 14, this is when I'm asking everyone to do some calculation here and simplify your question. Simplify your expression. So I will have x squared. If I bring this up, I should have x multiplied by -1/3. Alright, okay, so now I'm going to apply the exponential operation. I multiply the two power with the same base, so I just have to add the two exponents. Alright, then I should have x squared plus -1/3. Okay, so this will give me 2 subtract 1/3. It should be x to the exponent 5/3. Okay, so 2 minus 1/3 will be 6/3 subtract 1/3, so it's 5/3. So it's just a quick fraction reminders here. Okay, so number 15, I'm going to leave this two numbers as just the fraction, and I just work with the expression in terms of x, so the radical in terms of x. So this is x to the 1/2, and I multiply that with x to the -3/5. Okay, so in this case is 2 over -3. X will be 1/2. Add that with -3/5. Okay, so in this case, what do I get? 1/2 subtract 3/5. So I will have 5/10 subtract 6/10. So in this case, I should have -1/10 as my fraction. So then this will become x to the exponent -1/10. So double check, we are good. Double check, we are good. And the same thing here. Alright, okay, so everyone kind of understand the purpose of this question. A lot of practice for us to recognize when to convert this to a negative exponent, and what do we have to do to simplify them, and using the concept of operation of exponent. And I do have quite a few questions for everyone to work on, and please make sure that you spend some time to work on this exercise. The reason I emphasize this and I assign everyone quite a bit of question to work with is because in order for you to do the calculus correctly, you want to build the good foundation, right? So you need to make sure that you master this before you can work with your basic operation of calculus. Because if you convert to a wrong exponent and still apply the correct concept of calculus, your solution is still incorrect. Therefore, it's very important, and I want to remind everyone to, after you finish listening to this video, I would like you to download this document here, okay, and then start working on it. And I do have a solution posted online. Okay, thank you everyone.